Okay, hello. This is the second attempt at recording this. I hope it doesn't go wrong again. But hello, I'm recording for you, student Natasha Thomas et al. This is me going over those quiz questions, or that quiz question that you wanted. So I'll go from where the image starts. It says ship A is 12 kilometers due west of ship B. Okay, so ship A is here, ship B is here, and there's A is 12 kilometers west, so I think that means that's like this, right? We'll go kind of, that's north, that's east or whatever. And ship A is heading north at a speed of 21.7, and ship B is heading 24 degrees west of north, so that's kind of this direction. Was it 24 degrees? 24.4 degrees. So that's 24.4 degrees in there, and then the value is 42.0 kilometers per hour. Right, so this is in kilometers per hour, but I think the it requests kilometers per hour for the answers. Okay, and it wants VBA, right, velocity of ship B relative to ship A. Now, I don't understand why the question asks you to draw the vectors, but sure, right? The reason why I don't understand is because the answer is expecting it in I and J notation, which we can solve really easily. So the first thing we're going to do is we're going to understand that we need to perform some sort of subtraction, some sort of addition, and we have two vectors, right? We have this one, we have this one, and we have no idea how we're supposed to add them or subtract them or whatever. So first things first, we must depend on our vector addition and subtraction formula. So we know that VBA is going to be VB something plus V something A, and of course the something is the water, right? Because this, right, this vector here is the velocity of boat B in the water, and this is the velocity of boat A relative to the water. So we can put BW here, that's what we want, the velocity of B in the water. I just realized my head's in the way. My head's here now. And then we need V something A, obviously it's going to be VWA, right? Now we know that you can multiply a vector by -1 to reverse the indexes, so this means that VBA is actually VBW minus VAW. Cool, so far so good. So this is our vector equation, right? It's asking us what VBA is, and we've come up with an equation that's going to tell us what VBA is. Now, if you were interested, what you would do, right, is you would do one minus the other, right? So you would go VBW minus, oh, I shouldn't have drawn that there, maybe, whoops, drew through it, minus VBA equals, sorry, minus VAW equals this vector here. Anyway, we're not going to do that because it's dumb, right? We don't have right angle triangles. We don't really know what we're doing here. So instead, we're just going to do it in 2 dimensions, right? We're going to decide that this is the J direction and this is the I direction. I think that's what they've decided. Oh, what? Yeah, no, that's correct. Okay, good. I is east and J is north. Okay, so we're going to do I is east and J is north. I'll just rub this out because it's not very useful. And what we're going to do is we're going to take this equation and we're going to decide that it's 2 equations, okay? The velocity of B relative to A in the I direction is equal to the velocity of B relative to W in the I direction plus the velocity, minus the velocity of A relative to the water in the I direction. That's how we're going to solve for part I. And for the J part, for the J component, VBA of the J component is equal to VBW of the J component minus VAW of the J component. And that's all, right? Because this is orthogonal, these 2 directions, so you can just treat this 2-dimensional problem as 2 one-dimensional problems, which is the kind of power of index questions, of I and J indices, that's the way, the kind of power of I and J indices. So now all that kind of remains is to evaluate all of these things, okay? So first of all, let's do this. This one's pretty easy, right? It's 0I plus, well, I guess I should do comma. That's probably more obvious. 21.7, and this is still kilometers per hour, but that's okay because that's the units the question is asking for, j. Okay, and then this b vector, or vbw, we'll have to, so I don't know how to zoom out on this thing, so, I can't do that infinite zoom that I do. It's going to be this I component here, right? I guess I should draw it all the way. The BW J component, not I, J component, sorry. I know my head's disappearing, but I'm just writing on stuff. Maybe I'll move this down. There we go. Okay. Is 42.0 cosine 24.4. And this component here is 42.0 times cosine of 24.4. Okay, so I just realized I don't have a calculator on me, so I'm just going to Google that. Oh, no, I'm not going to Google that. I forgot that my screen's up. I'm going to pause this. I'm going to calculate it. All right, I did my calculations. They're in black now. So the I component, right, of this BW vector, this is VBW of the I component, right, is minus 17.35. It's minus because it's going west, and its east is positive, right? That's what the question told us to find. And then BW in the J direction is 38.24. So velocity of velocity of B relative to A, BA, the X component, or the I component if you want to be weird about it, is going to be BW in the I components. That's minus 17.35, minus 0. So from the perspective of ship A, ship B is moving to the left, which is good. That's what we're expecting to see. So that's equal to minus 17.35 I. And then the J component this is equal to BW in the J component, which is 38.24 minus 21.7, which is equal to 16? No, what's that, 16? Yeah, 16 point, screw it, it's 16.5. I know it's not 16.5, but I can't do that maths in my head. It's too sleepy. All right, there's my head now. Head's here now. Okay, so that's the J component. Okay, so J. This is telling us that the from the perspective of ship A, ship B is going up or going north, which should hopefully make sense because ship B is like going more north than ship A is. So from the perspective of ship A, ship B is traveling north. Okay, so that's the first question. I don't know why you wrote 3. I think that's you just writing it as like a guess answer. Anyway, then ship A and B, when ship A and B are located at the same westerly coordinate, what is distance is between them? Okay, that's a strange question, but I get it. Okay, so what they're asking us, and this is it's a strangely written question, but the math of it is a good idea. Okay, so what they're asking is, maybe we'll do a new page. New page, good. Okay, what they're asking is, so we have ship A here, and ship A is just going to keep going up, and ship B here is going to kind of go this way, right? And we want to ask, by the time ship B has gone this far, so it's in the same kind of axis as ship A. That's what it's saying there when it says when the I coordinate is the same. So when they're in the same horizontal, when the I coordinate is the same. Yeah, so when they're the same vertical plane, but it means they have the same I coordinate, right? Because they're in the same vertical line, which is I equals something, right? When ship B is in that same position, right, how separate are ships A and B in the vertical direction? That's what it's asking, right? When ship B gets to the same horizontal position as ship A, so when they're at the same horizontal coordinate or I coordinate, what's their difference in B? And that's that's 3 stages. 1, how long until B and A are same I coordinate? 2, how fast is V, B, A in the I direction, right? Oh, in the J direction, sorry. So this is how much faster is B going than A? Because we know B is gonna like overtake A, right? Because they started at the same vertical position, but by the time, because B goes faster in both axes, right? By the time B reaches this plane here, this line here, it's going to be ahead of A. So we need to know how fast it's going, and then we just do 3, right? Multiply 1 and 2 together. Now to show you what I mean, let's record the values we had last time. Oh, how do I do previous page? Okay, my wife wrote a cute message on my iPad, but I deleted it. Anyway, sorry. So we have here, what was I talking about? First of all, how long until B and A are the same I, right? The thing is that we know the relative velocity in the I direction, right? This is this thing here, right? So every hour, ship B moves 17.3 kilometers left relative to ship A. That's what this is saying, right? Because the relative velocity of ship B relative to ship A is 17.35 to the left, or minus 17.35 in the positive I direction. So question 1, right? How long does it take? Well, the time taken is equal to the distance, which, remember, they're 12 kilometers apart, right, in the horizontal axis. So it's 12, because we're doing kilometers per hour here, divided by 17.35. Okay. Don't worry about the negative, because I've taken that into account. We're just like kind of vibing in that direction. Sorry, this direction for how the recording works, I think. And that's equal to some number. Oh, hang on. I'm just gonna give me a tick. Whoop. Okay. 12 divided by, I really should get a calculator. 17.35. That's equal to 0.69916. Hours, right? So that's question 1. That's how long it takes. Now question 2 is, okay, how fast vertically is ship B going relative to ship A? And it's going 16.5 kilometers per hour relative to ship A in the up direction. So now what we need to do, I forgot already, is answer question 3, right? So the velocity of ship B relative to ship A in the J direction times the time taken to kind of meet is the vertical direction we're looking for, because they started, by the way, in the same vertical direction, in the same vertical position. Okay, they started horizontal relative to each other. So we're going to do 0.69 times 0.6916 times, I think 16.5. I don't know why I already forgot it. Yeah, 16.5. Okay, and that's going to be equal to, I don't know why it keeps showing up there. Sorry. 16.5, and that's equal to 11.412 kilometers, right? Because we're doing kilometers per hour. Okay, that's that. I hope this is useful.